Good afternoon, everybody. Our next speaker, Jessica McKellar, is an entrepreneur, software engineer, and open source contributor from Cambridge, Massachusetts. She is co-organizer of Boston Python, the largest Python meetup in the world, and runs the Boston Python Workshop. She's a maintainer for the Twisted and Open Hatch projects. And on top of that, she is co-founder and CTO of Zulip, an enterprise messaging service that was acquired by Dropbox last month. Today she'll be talking to us about security solutions and sandboxing with Python. Please give her a warm welcome.
Hey, everyone. Thank you so much. All right, so today we're going to talk about building and breaking a Python sandbox. And this is me. I'm also director for the Python Software Foundation. I am probably too involved in the Python community. Here are a couple of ways to get in touch with me. OK, so building a sandbox. Why would we ever want to do this? This actually comes up in a surprising number of contexts. When learning a language, some companies want to provide a hosted scratchpad for doing arbitrary computation. There are some researchers using distributed computation across a bunch of platforms where you need to run untrusted code in remote contexts. And there's some cases where you want to inspect running processes safely where a sandbox might be helpful. So a sandbox, the ability to run untrusted Python code. And there are a lot of examples of this in the wild. Seattle is an academic peer-to-peer computing network. Google App Engine has a Python shell. If you've ever used Code Academy, they use this mpython service to run a Python sandbox. And Check.io, who I think is at the startup row here, there's an online coding game that executes arbitrary Python code. And if you have visited the python.org website post-redesign, front and center on the front page is a Python REPL. And so this is running arbitrary code in a sandbox. And we have two big choices, or two big options when building a sandbox. We could do language-level sandboxing, which is what we're going to focus on in this talk, and then OS-level sandboxing. And these are sort of modeled by the PySandbox project and then PyPy's sandboxing model. And we'll talk about sort of the pros and cons of each later in the talk, but we're going to stick with language-level sandboxing because it is a lot of fun. It gives us an excuse to dig into some fun language details. OK, so our most fundamental question here is how do you execute arbitrary Python code in the first place? And we have two main primitives for this. We have eval, which compiles and evaluates expressions. And an expression is really just some stuff that reduces to a value, like 1 plus 2. And then exec compiles and evaluates statements. Statements are the smallest standalone chunks of Python code. Exec is more general because sort of all Python programs are made of statements. So we'll use exec as the basis for our sandboxing model. And we'll set up a little test harness here. We have a sandboxing class. It's really simple. It just has one method, execute, which takes a code string and execs it. OK, cool. So let's test this. So we'll create an instance of our sandbox class, and we have some really simple code. We'll just print hello world, and we'll execute that code. And this works. Great. OK, so we've now written a sandbox that will execute anything, but it works. Good. OK, so what are some things that we should disallow in our sandbox that is running untrusted user code? A lot of options. We definitely we don't want people to use up all the file descriptors. We probably don't want them to be able to start up a web server that is doing its own thing. Maybe they shouldn't be able to error out of the sandbox. They maybe shouldn't be able to read sensitive information from the file system. And this is just a partial list. So there are a lot of things to worry about if we're going to run untrusted code. To focus the discussion, let's use the ability to write to the file system as a good example of something that our most basic sandbox should not allow. Just because that represents the ability to probably do a lot of other things manipulating the file system. OK, so the thing that we're going to focus on in this talk is the ability to write to a file. We definitely don't want that to be possible. So currently this is possible. How can we prevent it? OK, well, what is file exactly? And if we do some poking around at the REPL, we'll find that if we poke around in this _builtins, file is in there. So file is one of the built-ins in Python. And there are a lot of other, so file is kind of problematic, and there are a lot of other potentially problematic built-ins that we might want to disallow in our sandbox. So how do we disallow the execution of problematic built-ins? Starting to build up the functionality of our sandbox. So, okay, here's one idea, just spitballing. What about a keyword blacklist? So, okay, you can't use file, you can't use eval, you can't quit. Let's just, we're passing in a code string. If we see the word file in our code string, raise a value error instead of actually executing it. Okay, sounds like a plausible idea. And if we try this with our keyword blacklist, this will in fact fail with our value error. Okay, good start. Can we get around this blacklist? Okay, so we're thinking, we're scheming, thinking like the attackers. Okay, well here's one idea. How about encryption? And not even super sophisticated encryption. By encryption, what if we just did this? What if we just rot13 encode the word file? So the literal text file never appears in our program, but we can decode it and look it up in the built-ins dictionary. And now that we have a reference to this file object, we can write to the file system. And so if we do this, it in fact works, right? Because our keyword blacklist, it never literally appears in the keyword blacklist. Okay, so blacklist, not so hot an idea. And the main observation here is if I can get a reference to something bad, I can invoke it. The name doesn't super matter. It's the actual reference that matters. OK, well, how can we remove all references to problematic built-ins? OK, well, a blacklist didn't work so well, but how about a whitelist, a built-ins whitelist? So we could literally have a set that enumerates all of the built-ins that we deem OK, and it leaves out the ones that we think are bad. And then before we actually execute any code, we could take this original built-ins and then iterate over all of the original built-ins keys. And if it's not in the whitelist, we'll just delete it. So it's not in the namespace anymore. OK, that sounds pretty good. Let's try that. So we've removed file. File was not in the built-ins whitelist. And if we try to execute our sample code, this in fact fails. So file is literally not defined. File is not a concept in the namespace anymore. Sweet. OK, so built-ins whitelist. OK, so I can't use file anymore. What else can I do to write to the file system? OK, well, what if I import something? Can I import? Oh, yeah, I can import OS, right? So I can import OS, and OS has an open function that is very similar to file, and I can use that to write to the file system. And so far, this is allowed. OK, so how do we prevent this from happening? Well, the problem is that I could import OS, right? So how do we disallow problematic imports? OK, well, the whitelist idea worked pretty well for the built-in, so why don't we try and import whitelist as well? But importing is kind of interesting, right? Because there's a whole mechanism around importing, and we're going to need to hook that importing mechanism. So I guess the first question is, how does importing a module work in Python? And if we poke around at built-ins a little bit, we see that there is this _ import in the built-ins dictionary, and if we get a reference to that and we give it the name of a module, that does the work of actually loading that module's information into the namespace. Great. So using _ import, we can sort of manually do the import ourselves through built-ins. And what is the expected function signature for the importer? Well, we can just look at that in the little built-in help here. And we see that we need a name, and there's some stuff about globals and locals and some other optional arguments in the function signature. Cool. OK, so let's write our own importer. And for starters, it is just going to print that we're, to prove to us that we're using our own importer, we're going to print that we are, and then we're going to use the underlying _ import that we pulled out of built-ins. And so if we do this, we see that it works. Cool. So we've hooked the import mechanism to use our own importer. And now that we've done this, we can extend this to, before actually trying to import something, we can check if the name that we're trying to import is in the module whitelist. And if it is, we use that underlying import mechanism. And if it's not, we block the import. We raise an import error. Cool. OK, so maybe we want to be super conservative. Maybe the only modules that you can import are string and RE. and we replace the importer that's in built-ins with our safe import implementation that's using our safe modules whitelist. Cool, OK, so now if we try using os.open, oh, I have warnings about meetings. Cool. Let's make that never happen again. Where's my point? OK. We're gonna quit this. I have a lot of meetings that I'm missing. OK. This is going to look really good in the video edit. OK, where am I? Oh, God. OK. Are we back? We're back. OK. OK, so we're going to try to import OS. And this doesn't work anymore because we have hooked the importer, and it's not in the whitelist. Awesome. OK, so whitelists are proving quite fruitful for us. Sweet. What else can we do? Okay, I can't import. I can't use file. What else can we do? OK, well, this is a little hypothetical. But one thing that we've been doing a lot is sort of munging built-ins. And if I can play with built-ins, then an attacker could too. And there's a lot of really fundamental stuff in there. Like this is in Python too. We define true and false in built-ins. Like what if an attacker set true equal to false and vice versa? At the very least, that could do. It's possible that that could cause all kinds of checks to behave unexpectedly. It seems like a bad idea to let people modify built-ins. So let's take that off the table. But then the question is, OK, how do we make us unable to modify built-ins? So we really want to make built-ins read-only. So how do you make something read-only in Python? OK, well, built-ins is a dictionary. We can subclass a dictionary. And why don't we just raise a value error for all of the things that would mutate the dictionary? Cool. OK, so we have a read-only built-ins class. You can't add or remove items from this dictionary. That sounds pretty good. And we can, again, before executing any of our untrusted code, we can replace the original built-ins with our read-only version. Cool. OK, so what else can I do? The main lesson that we learned earlier is that if I can get a reference to something bad, I can invoke it. Can I get a reference to something bad anywhere else within Python? Like, where can I poke around to get a reference to something that I could use to write to the file system? OK, well, there's a bunch of funky stuff in the inheritance hierarchy. Why don't we just play around there? Let's just poke around and see what we can find. So let's take a list. Let's run dir on list. There's all these double underscore methods that I usually just ignore in the dir output. Is there anything interesting in here? Well, there's this class attribute. OK, so list is a type list. Fine. The class attribute has its own attribute bases, which is what the object's base classes are. So in this case, list is just subclasses object. Not super interesting. But so you can get the base classes of an object. And you can also do the reverse. You can find the subclasses too. So in this case, list doesn't have any subclasses, but int does. So bool is a subclass of int. Str and Unicode both subclass base string. OK, so we can get the base classes of an object, and we can get the subclasses of an object. And the base class of list is object, which everything inherits from, right? What are the subclasses of object? That would be an interesting list of things. Whoa, OK, so that turns out to be a lot of things. OK, so this is all of the things that subclass the object class, the most fundamental class. And this is pretty hard to read, so why don't we write a little for loop to make this easier to see? OK. So we're iterating over these subclasses. And let's just print the name. We're sort of scanning through this. OK, sweet, instance, ellipsis, member descriptor. Wait a second. You thought you were gone, file, but you're not. OK, so file, we still have a reference to in one of the subclasses of objects. And once we have a handle to file, it's game over, right? We know exactly what to do with this. So we pull out the name. So we have these subclasses. We make a nice little dictionary mapping the name to the actual reference. We pull out the reference for file, and we use that to write to the file system. OK. Well, how do we stop that from happening? And maybe the thought here is that we really shouldn't be exposing these implementation details. Like maybe it's useful in some cases, but maybe for the vast majority of programming use cases, we could just hide these from the user. So let's see if we can just get rid of these. Can we delete bases and subclasses? OK, so we're going to del type.bases. Shoot, that did not work. And the reason it doesn't work is because this is actually, there's a check on doing this. You can't actually set attributes of type. This is imposed by the underlying C Python implementation. So we can't delete them from from Python. But fortunately, if we're willing to invest a little bit of effort, we can actually work around that. So there's this thing called ctypes. So ctypes is a foreign function interface that allows us to sort of dig into the underlying C Python guts. And so if we use ctypes, we can work up a little function that'll give us the dictionary of attributes on the underlying C Python implementation for something. OK, cool. So if we write up this little dictionary of function, we can pull out the underlying type dict bypassing this deletion check, and we can del bases and subclasses that way. Cool. OK. OK, so no subclasses, no superclasses. Now what can we do? What else can we do to write to this file system? OK, well, let's back to playing around here. OK, so let's say it was fruitful for us to look at some of these random double underscore attributes on list. Why don't we write a function and see if there's anything interesting in the dir output there? OK, so we've got hash, we've got name, we've got new. Func code. OK, that sounds interesting. What is func code? What's an attribute of func code? Cool. OK, so there's this CO code attribute of func code, and if we look at CO code, so, there's some sort of hex gibberish, which looks like the actual byte code that the Python interpreter is executing. So that's cool. Surely we can't change that, right? OK, so just as a sort of a prototype, OK, we have our nice function foo. And we're going to write our own evil function that prints kaboom. And if we run foo, it prints meow. But if we set the func code attribute on foo, what happens? Uh-oh. OK, so that works. OK, so that seems bad. OK, so this brings us back to an idea that we discussed before, which is that we got to be careful about exposing potentially dangerous implementation details. Probably in the vast majority of use cases, our users don't need access to a func code object. And actually, we can use the same ctypes trick from before to get rid of this. So we can use our dictionary of function to pull out the attributes of that function, of the function type, and then delete func code so it's not accessible anymore. Cool. OK, let's recap. OK, we tried a keyword blacklist. That ended up being a bad idea. Rot 13 was a big problem for us there. Builtins whitelist, though, that was pretty good. An import whitelist, so hooking the importer. Making important objects like builtins read-only by subclassing dict. We deleted a couple of problematic implementation details like bases and subclasses and func code. And then we deleted the ability to construct arbitrary code objects, which seems pretty dangerous. Sweet. And actually, we've run out of tricks. We have implemented, I would say, 80% of a full-fledged Python sandbox, where the remaining 20% are just edge cases due to details in the language. But if we zoom way, way, way out, you could imagine a single file containing all of the code we've written, where first we produce a builtins whitelist, then we have an import whitelist, and we make builtins read-only, and before we execute any code, we delete some of these problematic details. And then we'd have a pretty cool sandbox. It's pretty cool, although we do limit some important functionality. There are definitely cases where I might want to be able to write to a file, even in a sandbox. And also, if we think back to the things we said we should disallow, we're not hitting all of these bases yet. This language-level sandbox does not give us a lot of hooks for preventing resource exhaustion. Nothing would if someone decided to create a fleet of Bitcoin miners on my server, there are no ways to stop them from using up all my CPU resources with this implementation. And so going back to sort of our choices here, our choice was a language level sandbox, which was definitely fun to explore, or an OS level sandbox. And actually, the code that we've written, which is based on PySandbox, if we look at the GitHub page for PySandbox, there's even a nice strong warning at the bottom by the author, who wrote a really thoughtful retrospective on what he discovered while building up PySandbox over the years, which discusses a lot of the concerns that we've talked about. And fundamentally, it becomes hard to write a language-level sandbox that allows you to do useful stuff, but is also safe. And so his recommendation, and really the recommendation of most people that you talk to who have worked on sandboxes, is that you need to at least pair it with an OS-level sandbox. So leveraging the OS to enforce resource constraints or limit your visibility in the file system, things like that. But it was a fun exercise, no? Here's a little bit of food for thought here. So one question is, do other languages have these sandboxing concerns? What does JavaScript do? What does Java do? And also, if we were designing a new language, if we had the ability to do this from scratch, and we wanted sandboxing to be sort of a first-class consideration while designing this, what are some design choices that we would make? And here are a couple of fun experiments. This is the kind of thing that I would do on the weekend if I had more time. We could look into how PyPy does this. So we were looking, we utilized some CPython specific details while going through this experiment. How does PyPy do it? How exactly does the CPython interpreter compile and run bytecode? What does the Python stack look like? Coming from a C world, I have a very clear picture of that, but is it more complicated in the Python world? ctypes, this foreign function interface to be able to hook into C code, that seems like a very nifty trick. How does that work? And then how exactly can the operating system help provide a secure environment in this context? So a couple of fun experiments that we could run through together. And then also a little bit of bedtime reading. So the full PySandbox implementation, which is eminently readable and mostly what we've already talked about on these slides, actually. So it's up on GitHub. And then again, it's really thoughtful retrospective on PySandbox's challenges on LWN. You can read through PyPy's sandboxing implementation and how Python Anywhere, the service that hosts the python.org sandbox, how that works as well. So thank you for accompanying me on this journey through this tricky sandboxing setup to learn a couple of interesting language tidbits and sort of exploitation tricks as we walked through this thought experiment. That is what I have for you. So thank you so much. And then also, if you want to talk to me about this or anything, I will be at the O'Reilly booth in the expo hall tomorrow morning. You can get free books there. So thank you. Are there any questions? There are mics on the sides. Yeah.
Thanks for the talk. This might not really change the fundamental discussion very much, but if I want to sandbox something like IPython Notebook, have people worked on that at all? I mean, is in some sense that you can just run it through PyPy and use their sandbox? Like, are there any recommendations on how to do that?
Yeah, so I think, there are various mature sandboxing, certainly OS-level sandboxing techniques, and then PyPy definitely it's a supported operation to do things like this. So yes, I would say don't roll your own sandbox, and do use one that's established, yeah. Sandboxing horror stories, anyone who's worked on maybe JavaScript or V8 that probably has some, no? Okay, thank you so much. There are lightning talks next, so stay tuned for those.